Hey guys, welcome to Geometry with Mr. G again. Today we are going through the review for the first test of the third quarter. So I'm going to go through every single question here in detail and just try to help you prepare for that first test that you should have coming after this review day. Start with number one. A triangle has the sides 21, 32, and 50. What is the classification of this triangle? So when we're talking about this, we're talking about, is the triangle obtuse, acute, or is it right? Right? When we say classifications, what we're talking about, what kind of triangle is it, right? And you can notice that by looking at the answer choices. So remember, this is where we have that c squared box a squared plus b squared. And the reason why we have a box is because, remember, if it's greater than, then it's going to be obtuse, right? If it's less than, it's going to be acute. And if it's equal, then it'll be right. But we don't know what goes in the box yet. We have to solve and figure it out. So C is the most important side in Pythagorean theorem. That is always our biggest side. So 50 is our C. And it doesn't matter what A and B are. I'll just do it this way. So let's see. We're going to have 50 squared box. Then we're going to have 21 squared plus 32 squared. And the rest of this you could just put into your calculator. After putting that into the calculator, you should get these numbers. 50 squared is 2,500, and then 21 squared plus 32 squared is 1,465. So when filling in the box, 2,500 is obviously larger than 1,465. Therefore, this is an obtuse triangle. Okay, number two. Now, this one says, which of the following three numbers represents a Pythagorean triple, right? Represents a Pythagorean triple. Remember, Pythagorean triple, there are two things. Number one, they have to be all positive numbers, right? Positive numbers. And the second thing, they have to be whole numbers. So knowing that, we can actually eliminate answer choice A because A has a decimal in it. And you could eliminate answer choice D. And the reason why you can eliminate answer choice D, if you put the square root of 5 in your calculator, you will get a decimal, right? Square root of 5 is actually equal to 2.24, which is a decimal. So D cannot be the answer either. It's not a whole number. So then we're left with B and C, which they're all positive and they're all whole numbers. So how do we determine which one is the correct answer? What you're going to have to do is pick one of them and actually use the Pythagorean theorem and see if it works. So for example, let's say I use answer choice B. I have C squared equals A squared plus B squared, right? That's our formula for Pythagorean theorem. Now, it has to work in this formula in order to be a Pythagorean triple. So if I use an answer choice B, this would be my C, right? I can call this my A, call this my B. We're going to have 15 squared equals 8 squared plus 10 squared. This is going to be 225 equals 64 plus 100, which then evaluates to 225 equals 164. Well, we know that 225 does not equal 164, right? This is false. Therefore, B is not the right answer, and we're only left with one answer, and that one answer is C. And you'll see, if you plug in C into the Pythagorean theorem, it does indeed work. So C would be the correct answer here. Moving on to number three. I went ahead and added the work for answer choice C just to show you. So again, right here, right, this is, if you wanted to check and make sure it was true, when you plug in the answers, the numbers for answer choice C, you do get that 225 equals 225, which is a true statement. Therefore, that is a Pythagorean triple. Cool, so now moving on to number three. So 3, 4, 5, and 6 are going to require us to draw our special line segments and triangles. So I went ahead and just drew the triangle for each one. Go ahead and draw your triangles for each one. And let's now draw each one together. So number 3 is saying perpendicular bisector. Remember, for perpendicular, you should be thinking 90-degree angle. And bisector, we're thinking middle, right? Middle or midpoint. Okay, midpoint. So for a perpendicular bisector, we'd like to start at a midpoint. So I'm going to start down here with a midpoint. And if this is a midpoint, I know I can put a hash mark here and a hash mark here. And it has to create a 90-degree angle. So I'm actually going to go straight up with this, right? Straight up. And put my boxes here, showing that that is a 90-degree angle. Cool. So that's a perpendicular bisector. Angle bisector, well, what are we doing here, right? We're cutting an angle in half, right? So cut angle in half. So let's just draw a line doing like that. Close enough, I think. And then put a little arc, showing that those two angles are congruent. Now remember, this right here is not necessarily a midpoint, right? Do not assume that that is a midpoint. The only thing we know about an angle bisector is that the two angles are equal. That's all we know. We know nothing else, okay? You don't know anything else about it. So don't assume that. Make that right. There we go. Cool. Median. Well, median starts at a vertex and it goes to the opposite side midpoint. So this one does go to a midpoint. Therefore, we can add hash mark. Now, just like I just said on number 4, we can't add arcs, right? We can't add arcs in the angles. You have no clue that those angles are being cut in half. We do not know. Don't add any arcs into the angles unless it says this is also an angle bisector. It doesn't say that, right? It's just a median. All we know is the midpoint. So I'm going to erase that. And then the last one, number 6, is an altitude. Remember, for altitude, we should be thinking height. So straight up and down, right? Standing straight up and down. So if I start at this vertex, I'm going to go straight down to create a 90-degree angle. And that is an altitude. So those are your 4 special line segments. So for number 7, it says, given triangle ABD with median AC. So keyword here is median, right? And it's saying that AC is a median. So this line right here is our median. Cool. Well, if AC is a median, we know that point C is a midpoint, right? So if C is a midpoint, we could say that this piece is congruent to this piece, right? DC is congruent to CB. Continuing to the problem, it says BC is 4x plus 3. So I'm going to put 4x plus 3 right here for BC. And it says that CD is 2x plus 11. So I'm going to put 2x plus 11 right here. It says find BC. So this is going to be one of those problems where when we find x, right, we're not done. We have to go back and plug it in to find BC. But we have to first set up an equation to solve for x. So what I noticed about this, I'm going to call this my part 1 and call this my part 2, right? We got 2 parts here. And we know already that these 2 parts are congruent, right? We have the hash marks here. If 2 things are congruent, they're also equal. So we can use part equals part, right? Part equals part. So one part I got is 2x plus 11 equals, the other part is 4x plus 3. Go ahead and draw our line, and let's do some algebra and solve for x here. I'm going to do minus 2x on both sides. That's going to leave me with 11 equals 2x plus 3. Subtract 3 from both sides. Now we get 8 equals 2x, and then I'm going to divide by 2 on both sides. So we end up getting that x equals 4. Now be careful, that probably will be an answer choice on the test. But we are not done, right? We need to find BC. That's what it's asking us to do. So, well, BC is equal to 4x plus 3, right? I got that from right here in the problem, right? That's what it says right here. BC is 4x plus 3. We're going to take this 4, and we're going to plug it in right here. So this is going to be the same thing as 4 times 4 plus 3, which will equal 16 plus 3, which is 19. And that is our answer for number 7. So now we're looking at number 8. It says line segment MO is an altitude. So this is our keyword, altitude. And it says MO is the altitude, right? This one right here is our altitude. Well, we know that altitude means 90-degree angle, right angles. So we can say that this is a 90-degree angle, and this is a 90-degree angle. Those 2 angles are going to both be 90-degree angles. Find the measure of angle OMP, okay? So we got to identify where is OMP. A lot of us still struggle with identifying where angles go. So if I start at the first letter, right? The first letter is O. So I'm going to go O to M, M to P. Look at the angle you just created. It's where the 2 lines meet, right here, right? I'll put X there. That's what we're looking for. We're looking for the measure of that angle there, okay? So how do we do this? Well, I know 2 angles inside this triangle right here, right? I know the 55, and I know the 90. And we know that all 3 angles in a triangle have to add up to 180 degrees. So let's do 90 plus 55. That's going to be 145. Then we're going to take 180, right? We're going to subtract 145 from 180. So 180 minus 145. Do that in the calculator. you should get 35. So the measure of angle OMP will equal 35 degrees. I just want to mention that on number 8, a lot of people are probably going to assume that this angle and this angle are the same because they look similar. So a lot of people are going to say, oh, this is 60, so then therefore this one over here is 60. But as we just proved and as we just showed, it's not. In this situation, it's actually 35, right? And those are two completely different numbers. I just want to let you know, unless the problem says that this is an angle bisector, that MO is an angle bisector, you cannot assume that those two angles are congruent. Just keep that in mind. Okay, so we have 3 problems here, 9, 10, and 11, where we have to use this picture to determine if they are true or false, okay? Important thing is it says that the median is BF, so I'm going to use different colors here. So B to F is the median. Now, if that is the median, we know that A to F is going to be congruent to FC, right? FC. I'm just going to use singular tick marks, same colors, so you can see that. And then we know that, let's use here, we know that altitude, BD is an altitude, so B to D is our altitude, which means we should have a 90-degree angle, which we do, right? We have the box here, so that's good. And then it says that BE is an angle bisector, so this one here is an angle bisector. Well, if that's an angle bisector, you know that this angle is congruent to this angle, right? Those two angles must be congruent if that's the case. So let's see if these are true. Looking at number 9, it says A to E is equal to EC. Well, remember, what I would look at here when we see that we're talking about two sides being equal, let's look at the median, right? I would look at medians. Remember, angle bisectors and altitudes have to do with angles, whereas the median has to do with the midpoint. So if we're going to say two things are equal, two sides or two parts are equal, when we're talking about sides, I'm thinking median here. But the median, it says the median is BF, right? B to F, which is our blue line, right? The blue line right here. This is our median. And that goes from A to F, not A to E, right? So I already know that this has to be false. It should say AF is equal to FC. That's what it should be. Right? Now let's look at number 10. AF equals FC. Hey, look at that. Isn't that exactly what we just wrote right here? So therefore, this is true. Right? That's a true statement. And that, again, that's because BF is our median. And then number 11 says the measure of angle FAB. So let's use some colors here to find these angles. FAB. Where's FAB? So FAB. So that's this angle here. I'm going to use two arcs now. Is equal to the measure of angle FCB. FCB. So this angle here. It's asking, are those two angles equal? Now, just by looking at this picture, maybe, you know, they look like one. This angle here looks slightly bigger, right? Angle C looks slightly bigger. We're never to assume, right? We're not supposed to ever assume, though. But the answer to this one is false. And the reason why we're going to say false is because we don't have enough information. We don't know for a fact that these angles are equal. So false. Because the only angles we know that are equal are these two up here where we put our single arcs because of the angle bisector, right? Remember, B to E was our angle bisector. So we know that angle should be, use a different color. I'm going to use black for this. We know that angle A, B, E, so angle A, B, E should equal the measure of angle. Well, the other angle will be C, B, E. Those angles are equal. That's all we know. We don't know anything about FAB and FCB. At least there's not enough info. So that's why we're going to say that one is false. Moving on to number 12. So for 12 through 15, all we're doing is matching our points of concurrency to a picture. And here's how I like to do these problems. I'm going to get my highlighter here. I like to just look at, let's start with number 12, just to look at a single line segment. So I'm going to look at just this line segment here. I'm highlighting Q to U in yellow, right? I'm looking at just that line segment. I'm going to ask myself, what is happening in this picture? What is happening in this line segment? Well, I noticed that it creates hash marks. Okay, so this must be a midpoint. And I notice that it starts at a vertex up here, right? It starts at a vertex, goes to a midpoint. And that is the definition of a median. Therefore, we ask ourselves, right, if we remember doing Pythagorean, medians create what? What do medians create? Well, medians create the centroid. So centroid, the 12 will be answer choice C. In case you forgot which C goes with which letter, because you might be thinking, well, median, M goes with C, right, in Pythagorean. How do you know it's centroid or circumcenter? The way we remember that is, I'm going to use this one over here. This C goes with this P. Circumcenter has more letters than centroid, and perpendicular bisector has more letters than median, right? So the two with the arrows up here, again, right, this P and this C, they go together because they have more letters. So, and it's the same thing with this one here, okay? This one comes first, so it has, because it has more letters. Angle bisector has more letters than altitude, so it comes first. Angle bisector comes first. And that's just how we remember that. The ones with most letters come first. Just a little helpful tip to help us remember those. So I went ahead and highlighted one segment in each picture here, just to kind of speed this up a little bit. In number 13, I noticed that we got hash marks, which means this must be a midpoint. But we also have right angles, right? We also have a right angle here. So two things are happening here. Right angles, you should be thinking perpendicular, and hash marks, you should be thinking midpoint. Remember, a midpoint is a bisector. So this is a perpendicular bisector. Remember, 3 perpendicular bisectors create the circumcenter, right? They create the circumcenter. So 13 will be A. Go to the next one. We've got what's happening in the pictures. Well, what we see in this picture, if I focus on the one that I've highlighted in yellow, all we see are these 2 arcs. So the only thing we see is the angles, right? Angles are being marked with something. And anytime we mess with the angles, you should automatically be thinking angle bisector. Nothing else is happening in this. So I know it's this one. Remember, this A comes first because it has more letters. So angle bisector creates, 3 angle bisectors create the incenter, and incenter is answer choice B. And then the last one here we see highlighted in yellow. It's just going straight down to create this 90-degree angle. And it's starting at a vertex, going straight down, creating that 90-degree angle. This is where all 3 of those altitudes intersect. And we know that 3 altitudes intersect and create the orthocenter. So this is answer choice D. Moving on to number 16. So number 16 says, if point I is the incenter, so incenter is key here. And remember, right, if I do my Pythagorean, okay, where's incenter? Well, incenter is right here with this I, right? And incenters are created by angle bisectors. So when you think of incenter, you should be thinking angle bisectors. So each of these line segments here, right, the ones I'm highlighting in yellow, all 3 of these are angle bisectors. That's how we create this point I right here, which is the incenter. So continuing to read the question, it says, what is the measure of x, y, and z, right? The measure of x, y, and z. So let's find the measures of all these angles. Well, we know that if these are angle bisectors, that, for example, this angle must be equal to this angle, because angle bisectors means the angles are being cut in half. We know that this angle is congruent to this angle, so I'm using 2 arcs now. And we know that this angle, so 3 arcs, is congruent to this angle. All of the angles are being cut in half. So x and y are very easy, right? Because we should see that if this is 35, then this has to be 35. So x is going to equal 35 degrees. Let's see, if this is 20, then y must be 20. So y is going to equal 20 degrees, right? Now z is a little different here. What we need to do here for z is we need to figure out what is this whole angle measurement, right? If we knew the whole angle measurement, we could just divide it by 2, since we have 2 equal parts, right? Equal part here and equal part here. So let's figure out that whole angle measurement. The way I'm going to do that is by doing, let's look at this angle here first, angle E, so up here. 35 plus 35 is going to be 70. So this whole angle is 70 degrees, right? 70 degrees. Then we're going to look at n, right? N's over here. This entire angle is going to be 20 plus 20. So this is going to be 40 degrees. And we know that all three angles in a triangle, right? All three angles in a triangle must add up to 180. So if I do 70 plus 40, I'm going to get 110. 180 minus 110 is 70. So that tells me that this whole angle C, right, this whole angle over here, erasing that blue, this angle altogether is 70 degrees. Now, we have an angle bisector, though, that's cutting it in half, which tells us that each of these are going to be 35 degrees. 35 degrees, right? Because 70 divided by 2 equals 35. So Z is also equal to 35 degrees. There's all three of our angle measurements. So looking at number 17, it says, which point of concurrency, okay, so let's make sure we understand this, which point of concurrency, if we write out PAMA CCO, remember, PAMA is our line segments. These are our line segments. CCO represents our points of concurrency, right? So we're talking about CCO. One of our answer is going to come from CCO. Which point of concurrency is also known as the center of mass? Cool, this is the easy one. The center of mass, or the point of concurrency that's also known as the center of mass, is actually the centroid, right? So that's your answer for this one. Should be an easy one. The only reason I wrote the PAMA CCO on the side here is I just wanted to let you know that PAMA, right, our answer choices could not come from here, right? None of these could be our answer choices because it says which point of concurrency. Well, only CCO are points of concurrency. PAMA are line segments. So our answer could only come from the CCO side. Okay, moving on to number 18. Number 18 says point T, so point T right here, and put a little red dot there, is the centroid of triangle SOX. If XT, so X to T is, I'm going to use a different color for that. X to T right here is 18. What is the length of LT? So ultimately, we are looking for the shorter part here, right? L to T. We're looking for this piece here. I'm going to put an X here. So this is going back to knowing our centroids. So let's look at this. If I redraw this centroid going from outside the triangle, going from here to here, right? It's going from L, right? Because there's an L right here, to X, right? Because there's an X over here. And T is somewhere about right here, right? Because that's where you see the point T right there, I haven't read. Well, L to T, we don't know. That's X. Well, and T to X is 18, as given from the problem. That's what the problem told us. Remember our centroids. Remember our centroid, we should be thinking 1/3, 2/3, right? 1/3 and 2/3. So again, from L to T, that's 1/3 of the whole, and from T to X, that's 2/3 of the whole. Well, remember, to get from 1/3 to 2/3, right? To get from here to here is times 2. Well, to get from here to here, that's just the opposite. You divide by 2. So all we're going to do is take this 18 to get from here to here, and we're going to divide by 2. 18 divided by 2 equals 9. So there's our answer for number 18. Number 19. So this one talks about hinge theorem. This one's using hinge theorem. It says fill in the blank below. So we have AB. AB is this side here. And the angle across from AB is 85 degrees. So I'm going to just put 85 below here. And then we have DE. We're comparing it to DE in this triangle, which the angle that's opposite of that side, right, it's 41 degrees. So I'm going to put 41 here. And it's obvious to tell that 85 is greater than 41. Therefore, AB must also be greater than DE. So this would be our answer for this one. Now remember, we can only do this because we have one pair of congruent sides, two pair of congruent sides. As long as you have two pairs of congruent sides, you can always use hinge theorem to figure these kind of questions out. So our answer is answer choice B. Moving on to 20. So for this one, it says, given triangle KLM, list the sides. I want to list the sides from shortest to longest. Okay, so in order to do this, we need to know the angle measurements. And right now, I know angle M, I know angle K, but I don't know angle L. We can figure out angle L, though. We know that all three angles in a triangle add up to 180 degrees. So let's do 66 plus 88. And that's going to give us 154. 180 minus 154 will give us 26. So we just found that angle L up here is 26 degrees. Now that we know all three angles of this triangle, we can now determine which sides are the shortest all the way up to the longest, right? So the shortest side will always be across from the smallest angle. Our smallest angle is the 26 degree angle. So I'm going to draw my arrow pointing opposite of that angle, which points at the side MK, right? M to K. So MK is our shortest side of this triangle. Our next smallest angle is 66, so I'll circle that. Draw my arrow going to the opposite direction, right? Opposite direction would be going to this side here, which is LK. So LK is your next shortest side. And then last, our biggest angle is 88 degrees. And my line going opposite of that, right, going to the opposite direction, that's going to be ML. So ML is our largest side. Now for 21. Now for this one, it's saying list the angles. So this time we're just listing angles from largest to smallest. So in order to list angles from largest to smallest, we need to know the side measurements, which we do, right? We have 10, 12, and 16. We know all of our side measurements. So if I want the largest angle to come first, we need to find the largest side. Here's our largest side, which is 16. If I draw my arrow, it's going away from it, opposite direction of it, right? Across from that side would be angle B. So angle B will come first. That's the largest angle in this triangle. The next biggest side would be 12. And the angle across from that, or furthest away from that, would be angle A, right? So angle A comes next. And then the next biggest side, or the smallest side in this case, is 10. And the angle that's across from that one, right, is angle C. So angle C is actually our smallest angle in this triangle. Now time for 22. 22 says, Ms. Smith is trying to cut a triangle out of a piece of wood for home decor. Which of the following sets of numbers could represent three sides, right? Could represent three sides of her triangle. That's what we're looking for here. So if you remember this, we need the formula medium. What is it? Small plus medium has to be bigger than our largest side. So we're going to use this formula for all three. So if I start with number 7, for example, our small is 7 plus the medium is 12 has to be larger than 18. 7 plus 12 is 19. Is 19 greater than 18? And that does check out. The answer, that is true. So therefore, A is actually an answer. We don't have to keep going. And if you don't believe me, right, you could keep checking, right? We've got, for the next one, 10 plus 13 is 23, right? And 23 is not bigger than 25, so that's wrong. 4 plus 10 is 14, which is not bigger than 20, so that's wrong. And then 7 plus 7 equals 14, and 14 is not bigger than 14, right? 14 equals 14, but it's not bigger than 14, so D is also wrong, making A our correct answer. Next is 23. So 23 says the lengths of two sides of a triangle are 32 and 45. What is the range of the possible measurements of the third side for this triangle? Oh, this is easy. Okay, remember this. All you got to do is add and subtract, right? We add 32 and plus 45, and we subtract 45 minus 32. So we're going to have some numbers here, less than x, less than some number here. And remember, to get the numbers, we need to subtract and we need to add. So 32 plus 45 equals, that's going to give us 77. So that's going to be we added, so that's our big side, right? Right, this is our added side, this is our subtracted side. And then we have to do 45 minus 32, right? And that's going to give us 13. So this would be 13. So our answer is x is bigger than 13, but smaller than 77. And there's our range. And I just want to mention real quick on 23, another way you might see another teacher do this problem is big plus small and big minus small to get your range. So for example, right, 45 would be my big and 32 is my small. So you get 42 plus 35, which equals 77. And then big minus small would be 42 minus 35, which equals 13. And that's how we get those numbers. It's the same thing, just different use of big, using terminology such as big and small. Either way will get you the right answer. Moving on to 24. So for number 24, we've got, I went ahead and drew the picture just to kind of save some time. It says you're trying to rescue a cat. So I have my cat, right? Here's my cat here, that is stuck in a tree. The cat is 15 feet above the ground. So from here to here is 15. He's 15 feet above ground. And you have to place the ladder 12 feet away from the tree. So obviously ladders are leaning, right? So this side represents my ladder. This is the ladder. And it has to be placed 12 feet away from the tree. So we're talking about right here. Because of the puddle, right? There's a big giant puddle right here. I try to draw a puddle for y'all. How long does the ladder have to be? So how long is the ladder? How long is the ladder? That's what we're looking for. So this is my real life picture. If you look, what we have here, we have basically drawn, I'll highlight it for you, a right triangle. So from here to here, from here to here, and from here to here is our right triangle. I'm going to redraw the right triangle to make it easier to see out here. So we've got boom, boom, boom. And this is a right angle because the tree makes a right angle with the ground. Going straight up, the tree goes straight up, so that makes a right angle with the ground. This is 15. This is 12. What is the length of the ladder? How long does the ladder have to be? So we're looking for x. So this is a right triangle. We know two sides of the right triangle. Anytime you know two sides of a right triangle, in order to find the third, you should be thinking Pythagorean theorem. So c squared equals a squared plus b squared. Now the side that is across from the right angle, right, this side here across from the right angle, is always the largest side of the right triangle. So this is my C. I'll call this one my A. I'll call this one my B. A and B don't matter. So let's plug it in. We've got x squared equals 12 squared plus 15 squared, which leaves us with x squared equals, well, this side evaluated gives us 369. And then in order to figure out what x is, we must take the square root of both sides to get rid of the squared. So x will equal 19.21, right? So 19.21. So the ladder must be 19.2 feet or longer, right? My 19.21 feet or longer. So this is a good answer. I'm going to say x, right? X has to be greater than 19.21. And there you go. You are now done with the review.